Okay, this is question 12 on June 2016, paper 1. Polar bears have thick fur to keep warm. This photograph of a polar bear was taken using visible light. The diagram shows a thermal image of the same scene, and here we can see the polar bear, the sky, and the snow. Darker colors in the image indicate lower temperatures, so we can see that the sky is really dark, so this must be a very low temperature. That's going to be very cold. Discuss what information the image gives about the temperature of the object shown. So we're looking for just 2 marks here. So 1, we could say something about the bear, and we could say its fur, bear's fur and the snow are the same temperature because they are the same color. The bear's head and nose are warmer because those are lighting up. They're much brighter than everything around it, and the darker is something colder. You could have the sky or the air is cooler than the bear or the snow, or the sky or the air is the coldest thing. So the discussion, we're just looking at these 2 images and we're looking what's the difference between them, what similarities can we see, what information could we extract from them. There was a lot that you could have said for 2 marks there. You could have made some comparisons, you could have made some direct observations on it. So they're looking for you to tease out that information from the picture. The polar bear's fur includes short hairs and longer hairs. These longer hairs are hollow and contain air. Explain how its fur reduces the amount of thermal energy lost by the polar bear. Lots of things to say here. Again, it's an explain question, so hollow fibers, hollow hair. Take that off. Hollow hair contains an insulator. They contain air, which is a very good insulator. Air is an insulator, or it's a poor conductor. Therefore, convection currents, terrible. Convection currents cannot form between hairs. So we've got the bear, which is it's got its skin underneath the hair, and it's warm. So then these longer hairs trap the air, they're hollow and they trap air, and they stop convection from happening. They don't allow the warmer air that's above the bear to then go away and take the energy with it, otherwise it would start to cool down. One of the reasons why you wear big puffy jackets if you're somewhere cold is because you want to trap a layer of air so convection doesn't happen. Underneath its white fur, a polar bear has black skin. Describe how these colors affect the overall amount of thermal energy lost by the polar bear. Okay, so any 3 from black is a good absorber of thermal radiation. So white is a very good reflector, but black is a very good absorber. So black skin is a very good absorber of thermal radiation. And then, so you have lots of energy being absorbed by the skin. So you can have lots of energy being absorbed by skin to keep it warm. So any 3 from black is a good emitter or radiator of thermal energy. White is a good reflector of thermal energy. Black is a good absorber of thermal energy too. And the reflected thermal energy is absorbed by the black skin. So it's going to make some energy, and then that energy may be radiated by the black skin, but it's got white fur above it. That'll reflect the energy back, and it can be reabsorbed by the black skin. So it's a very good absorber and emitter. So these are things that you're looking for. Black being a good absorber and lots of energy absorbed by the skin. You could have also had the other way around, that white is a good reflector. Whichever one you chose, if you'd have made a good discussion of that, you would have got those 3 marks. The diagram shows another image of the same scene. The image was made during the day using ultraviolet rays from the sun. Brighter colors in this image indicates larger amounts of ultraviolet radiation. The gray line is added to show the position of the bear. Compare the observation and reflection of ultraviolet rays by the objects shown in the image. So snow reflects UV or does not absorb. We've got lots and lots of reflection here. It doesn't come from the snow, it's reflected. using rays from the sun. So it's reflected off the snow. You could say the sky absorbs UV. So not a lot of UV coming from the sun, coming from the sky. So it does not either reflect or absorb it. The bear's fur is a very good absorber of UV and does not reflect it. Bear's eyes are a very good reflector and don't absorb it. So 2 marks here, and look for that comparison again. Compare the absorption and reflection. So which is a good absorber and which is a good reflector of the UV rays. When you're looking for those comparisons, try and pick out, okay, this one's a good, but this one's a bad, and then explain why. 2 marks, and that should get you the 2 marks. Suggest why the sky appears dark even though the sun emits ultraviolet rays. So you could say that the sky, so look what it says, the sun emits ultraviolet rays. Why is the sky dark? Well, the sky doesn't emit UV. The sun emits the UV. The sun is not actually in our image, so the sky doesn't emit it. So if we looked at the sun, we would see it bright like the eyes or the snow. But the sky doesn't, so we wouldn't see it. The hollow hairs in a polar bear in a polar bear's fur are transparent tubes filled with air. It was thought that these hairs could act like optical fibers and guide ultraviolet rays down to the polar bear's skin. It is now known that this idea is incorrect. Ultraviolet rays do not reach the polar bear's skin. The diagram shows an ultraviolet ray entering the air inside a hollow hair. Suggests why this radiation does not pass down to the polar bear's skin. Looking for 2 marks here. We're just looking for suggestions. So you could say the ultraviolet light travels in air, not in glass or hair. Ultraviolet is absorbed by the hair, therefore total internal reflection does not happen. Explain why. So what we're looking for here, if it was going to go down the tube, we would have looked for it to do something like this. If that doesn't happen, it means that total internal reflection does not happen. So rather than the light being reflected within the tube, it must be refracted back out of the tube and not internally reflected. So there was a few things you could have said here. An explanation of why TIR doesn't happen would have been really good, because you should have noticed that this looks like an optical fiber. They thought it could be an optical fiber. So in order to get it to go down the tube, it would have had to totally internally reflect. If that does not happen, then it must be refracted out of the tube. They would have allowed here reflection in hair is external, not internal. There is no critical angle here. That is an explanation of total internal reflection. Okay, and that's the whole of paper 1.